Welcome. The title of today's notes worksheet is Polynomials Day 1. We'll be doing a lot of work with polynomial expressions, polynomial equations, and polynomial functions over the course of the year. So today's lesson just offers us an opportunity to develop the foundation for polynomials, to develop some of the characteristics, and then begin the process of the manipulations and operations with them. So we'll kind of start this out on your paper here. Let me go ahead and read what it says. In the expression ax to the n, determine the variable, coefficient, and degree. So maybe just use a little intuition here while I'm talking about it. If you can figure out which is which, three parts, a, x, and n, which is the variable, which is the coefficient, and which is the degree. Okay, well here's what I put in place. The variable, it's a very generic variable that we're going to be using over the course of the year, but the variable would be the x. The coefficient represents the constant out in front of the variable, and so I've got the coefficient being the a, and degree is just another word for exponent, and so as a result, the degree would be n. There's some words that you're going to see with this based on the number of terms in a particular polynomial. So we're going to talk about one-term polynomials, two terms, three terms, and then more than three terms. So see if you can fill this in, and if not, no big deal. I'll quickly run through. But a polynomial of one term, like this right up here, by the way, coefficient, variable, and degree just side by side, is what is called a monomial. So one term, monomial. Two terms, this would be the addition or subtraction of two monomials, would be a binomial, two terms binomial. The addition or subtraction of three terms, so three terms would be a trinomial. And then anything more than three terms, we just use the generic polynomial. So poly being many. So many terms right there. So you'll definitely hear me use those words over the course of the semester, so just be comfortable with that piece if you would. And then if you're still not entirely sure what's going on here, maybe let's get a little more concrete with this. Let's see if you can take a moment and write an example of a monomial right here, binomial, trinomial, and then a polynomial over here would be great as well. So your call on this, actually I'd encourage you to keep it in one variable if at all possible. So let's keep it in x, that's probably the most common that we'll use, and go from there. So write examples of each. All right, well I'll write down what I have on my paper. So here's just a nice straightforward monomial, there it is, coefficient, variable, degree. Not too many issues there. Let's see, a binomial, so two terms. So again, basically it's just two monomials separated by a plus or a minus there. 4x minus 1 perfectly fits in the polynomial family. And that would be a binomial right there. Nice. Trinomial, this is a fairly common one that we'll see, something along these lines right here. So the addition or subtraction of three terms. And then maybe, let's see, a polynomial, something like this would do. Again, totally arbitrary. If you have some different stuff on your paper, that's totally fine. But something like that, as you can see, I've got four terms going across there. Nice. Now what we want to do is be able to distinguish polynomials from all the other families of expressions that we're going to be working on. And so let's go ahead and put this piece in. As a matter of fact, maybe a little asterisk right there. Each term of a polynomial has a, and here we go everyone, let's write this piece in, a whole number exponent or a whole number degree. And so what a whole number is, just in case you're not sure, is 0 and then the counting numbers. So 0, 1, 2, 3, 4, 5, etc., right up the line there. So what that means is a polynomial cannot have a negative exponent, a polynomial cannot have a fractional exponent, a polynomial cannot have an irrational number as an exponent. Those are different families of expressions. So it must be a constant whole number for every single term in the exponent. So what I would love is for you to see if you could maybe put that together on example 1. Maybe a little intuition here, and see if you can go 5 for 5. Which of those are polynomials? Which ones are not? Can you do it? Well, you either did it or not. Let's see. I'm going to go ahead and go through the process and give the quick explanation behind it. So I'll start it out here, everyone. Letter A is definitely a yes. Absolutely. I have a 1x to the second plus 4x to the first. And look at those exponents, guys. Nice whole numbers. So yes on that. Letter B should be pretty straightforward as being a no. This is okay, but this term right here, obviously with that fractional exponent, is the issue. And again, if a term does not have a whole number exponent, it is very simply the wrong family of expressions. This one can be a little misleading, but actually this one is going to be a no. And as a matter of fact, 1 over x, if you kind of think about it, if we were to try to write this in the form that you see up here, where the coefficient and the variable and the degree are all kind of side by side, well, very simply, this would come on up. And when it comes on up, you think of this as being x to the negative first. So as a matter of fact, that is how that would look as a one-term expression. 1x to the negative first. Okay, so x to the first on the bottom is really like x to the negative first up above. And when it's written like this, then you can see it's a negative exponent. So a 1 over x actually is a different family of expressions that we're going to explore a little later on this semester. Letter D is another tricky one, by the way. And as a matter of fact, it's a yes. Kind of cool. So just a number like that actually does fit the characteristics that we've talked about. Here is the coefficient, of course. And in terms of the variable and degree, even though it's not written there, I guess the implication is that it's kind of like an x to the 0, or just a variable to the 0 power. Because everybody, what is anything to the 0 power? Just 1. And so this part is really just 1, and 1 times 4 is just the 4 that you saw. So there it is, a 4x to the first. And I kind of wrote a couple up here. You kind of see that I had a number on the back, and you know, I sort of played it out and considered that part of the polynomial family. And last one, letter E. Then I think once we have that, again, the coefficient's irrelevant, even though that's an irrational coefficient. That doesn't matter. It is the exponent. So you have an x to the first, and you have an x to the 0. And so the exponents are whole numbers. So there you go, guys. There's your 5 for 5. Wonderful. Okay. So the degree of a polynomial is the highest degree of all the terms in the polynomial. And so when we kind of multiple terms there, we just kind of look at each and every one, and whichever has the highest exponent, that is how we attach the degree. And so let's go ahead and just do example 2. We can do this fairly fast. And so example 2, determine the degree and the leading coefficient. So I hope everyone's all right when I talk about the degree here. I have a degree 2 and a degree 0. If I want the degree of the entire polynomial, very simply I just take the highest degree. And so degree 2 is obviously higher. To get the leading coefficient, all we do is figure out where the degree came from and then get the coefficient for that particular term. And so in this case, the leading coefficient is 4. We talked about this one already, just a constant right here, a number, has an x to the 0 implied on the back, so the degree is 0, and then obviously, in this case, the leading coefficient would just be 6. Nice? Letter C, let's get moving on this one. This would be an x to the first right here. This would be an x to the 0. X to the first is obviously the larger, so it is a degree 1 polynomial. And if I found my degree right here, then I just go right out in front where I found it, and the leading coefficient is -7. This one, maybe just a touch tricky here, but not too bad. I have a degree of 4, a degree of 0, and a degree of 7. And so the largest obviously would be degree 7. And where I found my degree, I go right out in front and find out that the leading coefficient there was a +6. Wonderful. Now, a lot of our work this semester dealing with polynomials will be in really 2 different forms, one of which we will call standard form. And so let's go ahead and just kind of write that down, and then I might go back to example 2 just to work on it a touch more. So here's what I wrote for standard form of a polynomial. If you could do the same, that would be great. Very simply, the terms based on degree are written in descending order. That's going to be the key. So as a matter of fact, just FYI on this, if you look at example 2, this actually happens to be written in standard form right here. This happens to be written in standard form. This one happens to be written in standard form. This one is not. Because if you look at the individual degrees, they're not going down in descending order. So why don't we just take a moment and just kind of write that off to the side here. Standard form here would be starting out with that 6x to the 7th. So we start with the largest degree, and then we go in just down in descending order. And so the next one would be the 2x to the 4th, and the next one would be the 10x to the 0. And so that would be the standard form version of that polynomial right there. Again, we'll be looking a lot at standard form, and then if you've ever heard the word factoring, we're going to talk a lot about these polynomials in factored form over the course of the semester. Okay, so good. I hope everyone's okay on that piece right there. Standard form, notice the degrees are written in descending order. All right, you're going to hear me use a lot of words that go with these degrees. Some are quite a bit more prevalent than others, but let's go ahead and fill in this table right here. So degree 0, we don't really do a ton of work with degree 0. I think I had already used this word for it. So degree 0 is just a constant, really just a numerical value. Degree 1, we're going to do a lot of work with degree 1 polynomials. They're linear. If you remember that mx plus b, here's an example of it right here. So this is a linear polynomial. And again, degree 1, mx plus b, if you kind of remember that situation. Degree 2, a lot of work with degree 2. So degree 2 polynomials are the quadratics. So something like this right here. Again, anything degree 2, quadratic. And then we start to get into the higher level degrees. And degree 3, do some work with degree 3s towards the end of the semester, cubic. Degree 4, a lot of work with degree 4s also. Degree 4s are going to be our quartics. And degree 5, not quite as much work with degree 5s, although we'll see some, would be quintic. Anything more than degree 5, then we just start talking about it as a degree 6, a degree 7, a degree 8 polynomial. So the classification here, please get to know those pretty well. Relatively straightforward. But again, you'll hear me use those words quite a bit over the course of the year. Nice. Let's keep it moving on to the next piece there. It is time to begin some of the operations with these polynomials. Obviously, what we'll do is start out with the easier ones and then work our way up. So adding and subtracting polynomials, really what it's going to boil down to, and I know you've seen this before in Algebra 1, but very simply, combine like terms. Apples to apples, oranges to oranges. Now, the one thing is, I seem to recall probably in Algebra 1 that you've looked at it in a couple different formations. You probably worked on adding and subtracting polynomials with a vertical formation and a horizontal formation. And the fact of the matter is you can lay it out however you'd like. I'm definitely not trying to reinvent the wheel here by any means. These are just laid out horizontally, and so that's just the way I'm going to go. But if you want to go ahead and write them vertically, please ask about that, and I can help you with that as much as you want. Okay, so letter A. Again, it comes down to is how many of each term do I have when I combine these together? And so if you look at this polynomial right here, add this one on, the question is, how many x squareds do I have? How many x's do I have? How many units do I have when I combine them together? So let's just talk it through nice and easy. I have negative 9x squareds in the first polynomial. I add 13x squareds in the second polynomial. And so I have 4x squareds total. Apples to apples. Okay, good. Now the next, I have 7x's in the first polynomial. I add negative 2x's in the second polynomial. And so without too much issue there, I have 5x's. Same deal here, everybody. Again, just understanding how to perform each operation. In this case, I have negative 5 units. I add 8 units. And so I have positive 3 units. And there you go. We started out with 2 quadratic trinomials. See those? Added those together. and I ended up still with a quadratic trinomial. Very nice. So quadratic degree 2, trinomial, 3 terms. 1, 2, 3. All right, good. Be careful on B and C. Tried to increase the level of difficulty on these. So remember, it's just the left one minus the right one. I have seen a lot of issues over the years with subtraction on polynomials, so be a little extra careful on these. When we talk about one minus the other, it's minus all of these terms over here. And we'll talk a lot about putting that second polynomial in parentheses like I did here. If you want to do the vertical formation on this, this would be the top, this would be the bottom. So we just write one over the other and do subtraction, aligning everything perfectly. Again, if you have an interest in exploring that, please don't hesitate to ask. In the meantime, I'm just going to take a look at this and try to keep it in standard form here. So I've got cubic terms, quadratic terms, linear terms, and constant terms. I'm just going to combine everything together. So I will be a little careful in this case. In this polynomial, if you really look, I have 0x cubes, but I'm going to take away 1x cubed. Is everyone okay with that explanation? So 0x cubed minus 1x cubed. Really, when I combine everything together, starting it out there, I get negative 1x cubes. Then I have a 1x squared over here. Take away negative 2x squared over here. Again, please be careful with your subtraction. 1x squared minus negative 2x squared should be 3x squared. And then here we go with the x's. Negative 3x's to start. Take away another x right here. So negative 3x minus 1x should be negative 4x. And last here, units, I start with negative 1, subtract 5, negative 1 minus 5 is negative 6. And there you go. You end up getting a nice cubic. There it is in standard form. Again, look at that, 3, 2, 1, 0 in terms of the exponents. And so this would be a cubic polynomial. Looks great. Okay, so we're going to go ahead and do this one. Work left to right, if you would. And, you know, subtraction, order does matter, so just please make sure it's this, and minus this. So I'm going to do exactly that piece. Again, if you want to set it up vertically, please feel free to do so. I'm kind of looking at my board here, and I see some cubic terms, quadratic terms, linear terms, and unit terms. So I'm going to combine them all together, working left to right with my subtraction. So let's start out with the cubic terms. I have 0x cubes over here, taking away 0x cubes from this one. So far I don't have any x cubes, but then I take away negative 6x cubed. So 0x cubed minus negative 6x cubed. I believe I have 6x cubes when all said and done. Okay, next piece. I have 8x squared minus 3x squared, so that's 5x squared. So I do this first. 5x squared to start, and then 5x squared minus negative 5x squared, and so I'm getting a 10x squared. Excellent. Let's keep it going. Maybe you're just ahead of me on this. That's perfectly fine. 7x minus negative 4x, that's 11x. And then it looks like I'm not subtracting any x's over here, so I think we have 11 x's. Okay, combine them together. And then let's see, I have a negative 5 units to start. It's not subtracting anything here, but minus 3. So negative 5, take away the 3, and I'm getting a minus 8. And that's what it's going to look like. So if you're not seeing one in particular there, please don't hesitate to ask. But when we add and subtract, especially with subtraction, be careful. Just combine the like terms and work in the appropriate order. Cool. Let's go on to the next piece. So the next operation, which we'll be working on here, would be multiplying two binomials together. So remember what a binomial looks like. And if you remember this word from Algebra 1, it's going to come down to FOIL. So just very quickly, you probably recall this. First, outside, inside, last. So essentially what we're going to do here is FOIL these out. I'll draw some arrows to start it out here, but it's basically this FOIL is just a shortcut way to talk about distributing, and that's how we multiply polynomials together, by distributing. So here we go. I'm going to do letter A, and it'd be great if you can, work on these as we go through. Feel free to fast forward the video if you know what you're doing. That sounds great to me. All right, so here we go. So first means these two together. X times x is 2x squared. Outside, so notice it distributes into that one. X times negative 3 is negative 3x. Then we go ahead and distribute the 4 in. So what that means is the inside, 4 times 2x is 8x, and then the 4 distributes lastly into the negative 3, so there's the lasts. 4 times negative 3 is negative 12. And that's looking pretty good, of course. Remember, this is addition and subtraction of terms. If I can combine terms together, then we certainly do. And in this case, if you see those middle terms right there, negative 3x plus 8x, sorry for the phrase again, but apples to apples there, and so those go together. And so we get that piece. Nice. Now, right now, foiling shouldn't be too bad for you, just working through. FOIL, and we get ourselves a nice looking quadratic trinomial out of it. The trick, of course, is in a day or two, can you make this look like this? This just happens to be what is called factored form right here. This is what is called standard form right there. We're going factored to standard right now. Soon enough, guys, we're going to go standard to factored. Some great stuff right there. All right, again, I would strongly encourage you just to pause the video and try them on your own. But I don't mind going through a couple. I'll just do them relatively fast, though. So first, 15x cubed. Outside, negative 9x. Inside, plus 20x squared. Last, minus 12. And that's good. I would encourage us try to just get in that habit. I'm a very visual person. I'll say that a lot over the course of the year. And it is helpful to kind of work in these in that nice standard form and just kind of get comfortable writing them in descending order. Not that this is wrong by any means, but that's fine right there in standard form. All right, good. Let's keep it going. Next one right here. This is an interesting one. So watch what happens in this case. I'm going to do my first. I get 16x to the 6th. Outside, I get minus 20x to the 4th. Inside, I get a plus 20x to the 4th. That's kind of cool. And then last, I get minus 25x squared. Take a look at that piece. Make sure it makes pretty good sense. And then when we do combine things together, it looks like those middle terms would combine together. And do you see that they would cancel each other out? I'm hoping that that clicks for you. And as a result, we're just left with this right here. Good. This particular expression has a name that kind of produces this expression right here. And vice versa, we're going to take this and kind of make it look like this in the near future, with maybe a slight variation on that one. Okay, good. Letter D. Be careful on this one. We'll kind of talk about this process as we go through, but remember what 3x minus 2 squared means. It means 3x minus 2 times 3x minus 2. So this is something that comes up a lot. A lot of students want to shortcut this. Can I just do 3x squared and 2 squared and call it a day on this one? No, unfortunately not. 3x minus 2 squared really means this, and when you FOIL, something tells me you're going to get something else in there, another middle term. So just be careful on that when you do this. Anyway, 3x times 3x is 9x squared. Let's get that. Outside, getting a minus 6x. Inside, also getting a minus 6x. And then how about a positive 4 on the back? Combine what you can, if you would, please. And hoping you're seeing a 9x squared. How does a negative 12x sound? And then the plus 4. And there you have it. Nicely done, just kind of working through, foiling. Again, should be pretty comfortable with that, given your Algebra 1 background. Let's go into kind of the last couple pieces here. Multiplying polynomials together when they get a little heavier. Very simply, we're just going to repeat the distributive property. So FOIL is the distributive property. When we kind of take it to the next level, we just keep going. So again, it'd be great if you're doing these maybe ahead of me and then just kind of checking your work on it. I don't know. It's up to you totally how you want to play that out. So what I mean by distributive property is we take one polynomial and distribute it into the second polynomial. So what we're going to do is take this 2x right here and distribute it once, twice, and thrice into that polynomial. Then we repeat. I'm going to take that positive 3 and I'm going to distribute it in once, twice, and thrice. So again, I think you've seen this before. Let's see if we can make this work. So it's up to you. If you want to go ahead and circle that 2x, that's not a bad idea, but it's going to go in 1, 2, and 3 times right there. So here we go. 2x times x squared would be 2x cubed. 2x times 4x is going to be 8x squared. And 2x times 5 is going to be 10x. Okay, good. Now, again, we just repeat. After multiplying that first term into the second polynomial, we multiply this term into the second polynomial. So here we go. 1, 2, and 3, everybody. So here we go. 3x squared would do. How does a 12x sound? So 3 times 4x. And then 3 times 5 gives us 15. Nice. We're rolling pretty well here. Just try to combine anything you can, addition and subtraction, and we've talked about this. It's all about combining like terms. So I have my 2x cubed. I'm getting an 11x squared on that, 22 x's as a result, and then 15 units on the back. Super. All right. Would love for you to pause the video, get a good abstract one for letter B. This is a good one, if you don't mind taking a look at it and then seeing if you got it right. And I'll give it a try myself. So I'm going to go ahead and distribute the x in 1, 2, 3 times. So let's do that first. X times x squared is x cubed. X times negative xy would be minus x squared y. X times x, of course, gives us the x squared. And then x times y squared is exactly that. xy squared. All right, there are your first 3 terms when you multiply it in. Now, let's go ahead and take this and distribute it in 1, 2, 3 times. So y times x squared. And if it's okay with you, I'm going to go ahead and just keep this as kind of in alphabetical order there. So y times x squared, there it is, right there. And in here, y times negative xy should be negative xy squared. Ooh, that's a good one. And then last there, y times y squared should be y cubed. And what did you notice when you tried to combine like terms together? And by the way, this is a like term with this, and this is a like term with this. They are the exact same degrees. And as a result, you see they're all opposites of one another. This cancels out with this. This cancels out with this. So those all go away. And as a matter of fact, there you go. X cubed plus y cubed. I think the trick for us, just FYI, is in the near future, we're going to try to make this look like this up here. Goodness. All right. Nice. So multiplication, there's some good stuff with that. Let's just do the last one here. We're actually going to see this model come up, kind of working with these open top boxes here. And so this expression is not as arbitrary as it looks. We'll see these values come up sometime in the future here. All right, well anyway, write a polynomial in standard form for the volume of the box. Hey guys, it's just a rectangular prism. So give me a little length times width times height on your paper. That would be ideal. And let's go ahead and put this together here. I'm getting a 10 minus 2x as the length. How does an 8 minus 2x as the width sound? And the height turns out to be x. Absolutely perfect. Now here's what I'd ask you to do. It looks like multiplication, so it's just this times this, and then that answer times this. So what you're going to do here probably is FOIL this out, so multiply that. Notice one binomial times a second binomial. So FOIL that out. After you get that, then what we go ahead and do is multiply it into the x right there. Be great again if you could pause the video just for a couple minutes, see if you can do it, and then come on back and see if you got it right. Okay, well here's what I did. I looked at this piece, and I FOILed, and I ended up getting an 80 for the first. Outside, I end up getting negative 20x. Inside, I get negative 16x. So that would give me a negative 36x, by the way. And then the last, I got a negative 2x times negative 2x should be plus 4x squared. Perfect. So that would be the polynomial when I FOIL these two binomials out. That's great. And now the only thing to do is to take that result and multiply it by the x right here. And so when we do this, I end up getting an 80x minus 36x squared, and then how about a 4x to the third? Something like that. If you left it like that, that's absolutely great. That would kind of be our answer here. It is a cubic polynomial. 3 terms, by the way, so I guess to be more specific, a trinomial. I'm going to go ahead and just put that in that standard form just one last time. Not that that matters too much, but something like that. And then you can really see there's the cubic trinomial right on through. And that looks great. So that is how we would multiply this out here. You multiply those, and then your answer you multiply into the x. Okay, so I hope this was, to some extent, a nice review, just dealing with polynomial operations. But just, again, some of those buzzwords that we went over, please just make sure you know those pretty well. You'll hear me use those time and time again. Hey, thanks for listening to the lesson, of course. Let me know if you have some questions as you're working through some of the practice problems. And that's great. Thanks for listening.